morning, sir.
So far, what is the topic that is currently running in your module? What topic is currently running? See, streams are running. How many weeks you have joined? 2 months. So what is your experience so far in these 2 months? Share your experience, 2 months. 2 months in vector versus 2 months in engineering college.
मला गुगल मेसेज मध्ये वाटलं काय फरक नाही वाटलं.
What is your experience? 2 months in vector versus 2 months in engineering college. No, let's consider 2 months of engineering college versus 2 months in vector. 2 months engineering college is very relaxing, right? Very relaxing, but here it is very deep. So don't you think that you should now go deep? Don't you think that you are a graduate now and you should go more deeper? How long you will keep on enjoying as with the engineering mindset? I think your engineering mindset time is completed. Now you should have to be a little bit more. मेल कसं करतो So maybe now you should post it. Turn it on. I don't usually like it. It's levels. For you there is AC, I can manage without fan and AC. For you there is AC, I can manage without fan and AC. Right. So what is the depth that you have learned so far in C language? Let me test. See, the moment I'm saying let me test, you are getting scared. Why are you getting scared? Have you not joined here for obviously getting into a company? So if not today or tomorrow, someday you have to go with a face off with an interviewer, right? So why not we start from the classroom itself? Why not we start from the classroom itself? So let me test how is your progress in the C language so far. I am not your C faculty, but I can ask ask you good number of questions in C. And to be frank, your comfort in C language in vector will help you float in the rest of the other modules in vector. Okay, your comfort in C language in vector will help you float in the rest of the other modules in vector. Otherwise, it will make you sink. So your sinking or drowning depends on your comfort level in C. That's why let's have a small test. And the purpose of this test is to also you should also know where you stand. Because whatever you are learning in C, somehow, somewhere, it will be applied in embedded C, that is microcontroller firmware development. It will be applied in, let's say, C++. It will be applied in Linux OS, what we call system programming. It will be applied in real-time operating system development. Okay, RTOS programming. It will be applied in networking with TCP/IP or network programming. So the comfort of C is going to be applied in the rest of the other modules. That's why I said that if you are comfortable in C, you will be able to navigate or float properly in the rest of the other modules. Your discomfort in C, anyway you are not comfortable in C, will give you a little bit burden on the head because you are not comfortable in C, and that burden will become more and more as you start going to the other subjects. So for you to reduce this burden, what is your responsibility? Practice. All the programs discussed in the class, all the exercises given in what we call your LMS or your, what is the other thing? Apart from LMS, any other thing? PPL, thank you. So, apart from your LMS, your PPL, or any hacker rank related websites, so your consistent practice in C will help you in the other subjects. Your inconsistency in C is going to make you drown. So the purpose of your joining this course, where you have paid a good amount of fees, your hostel fees, and your other extra expenses, all will be wasted. Emotionally, you will be disturbed at the end of the course when you are not able to present your knowledge that you have gained in vector properly. And you will be disturbed. Obviously, your parents who are depending on you or having hopes on you, they will be disturbed. So life is now very tough. Your enjoyment period of 4 years of BTech is completed. You have enjoyed, I have enjoyed. Okay. At least in BTech you have a chance of supplies and all these things to complete. But now, if you put here more supplies here, then you will be losing opportunities in the companies. And then the next freshers will be coming out, and then they'll be posing the competition and risk for you. So from that aspect, you have to be extra working here. I think maybe this lecture has already been given to you by other faculty, but it is our duty that we have to give you this realization. So the world is going to definitely distract you. The world is going to definitely distract you. And the first level of distraction is always carried with you. Your mobile. So the world is definitely going to distract you. Your first level of distraction is always with you. Distraction, sorry. First level of distraction. It is you to choose how much it should distract you or how much you can use it in a better way. At least during our time of your age, when we were at your age, we did not have that mobile phone and maybe we were saved by it. but we have to run a lot for acquiring knowledge. Okay, you are having knowledge, you are having technology in your pocket. We did not have that privilege during our times, and we had to go to libraries, go to internet cafes. Those people who are not able to afford computers had to go to internet cafes, pay around some 20-30 rupees per hour, and that's how we managed. But now technology has become cheaper, people are able to afford computers, people are able to afford good kinds of branded cell phones, iPhones, blah blah blah. But ultimately what is happening is they are getting attracted and mesmerized with the mobile phone features. But what is their features they are supposed to acquire to help them propel in the course, to help them propel in the life, that they are missing out. So I'm not saying mobile phone is bad. I'm saying that you should not get too much distracted by its use and spend so much time on it, which is not going to obviously pay off, rather than spend more time on something that is going to pay off for you. Right? So let us start. So I'll just ask you a few questions and then we'll get on with our course. So, what is meant by strong symbol, weak symbol? Yes, madam? Strong symbol, weak symbol. Please sit down. Storage class is completed? Okay. Not completed, so right. Can you list me all the bitwise operators? All bitwise operators without skipping any. Huh? Bitwise operators. Bitwise. Please do not open your books kindly. This is just a test of your readiness. Bitwise AND, bitwise OR. Bitwise XOR. You're stuck. So that's what I meant by readiness. You would not have been stuck had your practice in bitwise operators been consistent or vigorous. Had your practice in bitwise operators have been consistent or vigorous, this pause that you're having would not have come. So that means you're lagging practice. Can you tell me all the relational operators? Yes. Okay. What are the compound assignment operators? No? Compound assignment operators? Compound assignment operators. Right. What are the logical operators? Very good. What are the compiler stages? Yourself. Yes. Yes. Translator, linker, I think something. Say it in the proper order. After that? After linker? Exit? Execution. What do you call that execution? Before execution? Between linker and execution? What is it? Between loader. What is preprocessor stage? What is preprocessor stage? Preprocessor stage. What was your target today? To come? This was your target. What was your target today? What was your target today? What is your long-term target? To get a job in Vector. Through Vector. To get a job through Vector. Okay, so that is long-term this thing. So if long-term goal is there, can it be accomplished without meeting short-term targets? So long-term target is something that you plan to achieve. Okay? For that plan to achieve, there are steps, there are hurdles. Every hurdle you have to cross before you reach your long-term target. So my assessment right now, with respect to what questions I have asked you, is that you are not trying to meet your short-term targets first. Your short-term targets is to be ready on your toes, sorry. You are not on your toes as of now. You are still relaxed. And this relaxation will kill you. Kill you means not that kill you. Okay, so you are matured enough, you are big enough, you are old enough. You should now realize that what is required for you to achieve, you have to do something extra than what you normally do. Extra efforts, maybe some kind of timetable you have to prepare, maybe some kind of other sacrifices you have to make. You have to make some sacrifices to meet certain requirements. Shall we start? Let's see how you progress. Okay, so my module is basically called as the ARM, okay? ARM architecture. This is the name of my module. So for you to get comfortable with this module and to do something, to experience something practically and be able to pose yourself as as an embedded firmware engineer. Okay, so there are certain prerequisites that you need to fulfill. I'm just putting out the prerequisites right now. So prerequisites. Prerequisites. I repeat again. This is the name of the module. This module is going to go for about, let us say, 9 weeks for the ARM architecture. In addition to that, we'll be having the bus protocols that will be going for about 4 weeks. So, as per schedule, we can say 13 weeks. So 13 weeks we will be spending together. And for you to be comfortable during this 13 weeks tenure, from your side, you also have to put a lot of effort from your C language point of view. So your C practice should be keep on going on parallelly or concurrently. Your arm practice also should be going on. So for that, the first thing is the prerequisites is comfort in C language. Comfort in C language. This is the first prerequisite. The next prerequisite it is awareness. Awareness about basics of analog electronics. Similarly, awareness of the basics of digital electronics. Right? So these are the prerequisites. If you are able to manage these prerequisites from your side, I repeat, if you are able to manage these prerequisites from your side, you can manage the learning of the ARM architecture more comfortably. If your prerequisites here is not managed from your side, then definitely you will find it a little bit uncomfortable to be with ARM. Because first of all, when we are talking about ARM architecture here in the classroom of Vector, our focus is more on the what we call application aspect. Okay, it's not like an engineering college where we are going to just theoretically discuss and then close the chapters. Everything that we discussed, we will try to substantiate that using programming, then also application. In that sense, we will be going. Hence, you should be able to comfortable with C language, because we are going to use that language as a tool to design our embedded based applications around ARM. Okay, we are going to use C language as a programming language to design our embedded applications around the ARM architecture. We can use assembly language also. Assembly language is also a programming language. C++ is also a programming language. C is also a programming language. We are not choosing assembly language right now because again it will disturb you by learning. You have to learn another language, and that will again demand a lot of time and a lot of effort from your side. And from industry point of view also, that much preference is not given in too much knowledge, too much depth in assembly language. If you just have a little bit of information about assembly language, that should be sufficient. That will be discussed a little bit, but the main concern is in C language. So mostly from these last few years, let's say post-COVID, this last few years, mostly the interviewers have been targeting questions based on embedded C more rather than assembly. But pre-COVID, there were a lot of interviewers who were targeting students based on assembly also. So we were taking around maybe around 1 week to 10 days previously in teaching assembly that time. But after we observed COVID time, that asking questions on assembly has been drastically reduced, and more focus was being done on C. So from that aspect, we also had to move with that trend that was happening in the industry, that let's not give importance or waste time in teaching assembly now, because let's focus more on C. But assembly language is a separate language, C language is a separate language. To learn assembly language, you will also require an equivalent time that you are learning C language. Almost you can say you are, let's say 2 months, 1.5 to 2 months itself in Vector, you would required to learn assembly language. Otherwise, if you're going for BTech, then obviously a semester. In BTech also, a semester can be spent in learning assembly language. I'm not just saying learning about the syntax semantics. After learning, you have to see the applications, right? How you can use assembly language in writing numerous projects around it. So that is itself a separate language. Now, if we start inducing you with that language right now, again you will get stressed about, oh, this language is there, this language is there, how do I manage it? So your lucky point here is that interviewers are not asking assembly. That is your luck. After COVID, interviewers have stopped asking assembly or hardly asking assembly. So now your only focus is on C. But before before COVID, they had to practice assembly, they had to practice. But we will mention somewhere assembly discussions at some points because it will be required for discussion. Next, coming to the awareness of basic analog and digital electronics, because as we are talking about a technology or course called as embedded systems. What is the definition of an embedded system? Very good. So she is saying that embedded system refers to a combination of hardware and software for a dedicated purpose or a specific purpose. So software means instructions. Instructions will be binary. We never write programs in binary. We always write programs at a higher level, like assembly C. Then with the help of the tools like assembler, translator, we convert that into binary for the machine. Then hardware is talking about, hardware talks about electronics. Because embedded system is talking about combination of hardware and software. So what is the hardware? So majority of the hardware here is about electronics. So when we say electronics, obviously we have analog electronics, we have digital electronics. So you should be aware about some concepts of analog electronics and digital. What I mean by some concepts, now you should be able to remember what is the purpose of a BJT, what is the purpose of a FET, okay, what are the terminals of that. These small things you need to be able to recollect. What you had learned in engineering, you need to recollect it a little bit here because it will be applied. We will not be teaching analog here in the classroom. We will not be teaching digital because analog is a separate subject, digital is a separate subject. So we will not be teaching these subjects, but we will be using these subjects. We will be using the concepts of these subjects. Hence, my suggestion to you is, if you want to revise this at a faster pace, at a more comfortable pace for you people, I can suggest a few series of the YouTube. You can go for All About Electronics. All About Electronics is one series which you can try to spend daily some time, 10 minutes, 5 minutes, 7 minutes, 15 minutes, some videos are there. It will help you really, rather than opening textbooks and the black and white, it's sleepy and boring. This will, you can just revise it. Next you have the engineering mindset. Handwriting is not really that good, especially on the what is on the digital platform. But relatively on the board, it will be a bit better than this. So the engineering mindset. Okay, this is another YouTube series. You can try to look into this YouTube series. The beauty of this YouTube series is they have some nice, attractive animations. Okay, so animations are colorful. Colorful has effects on your brain. So you tend to remember things when there is a colorful representation of that. It's just like instead of reading something about Mahabharatam or Ramayana or some kind of things, you try to watch it in a colorful form, animated form. You'll enjoy it and you'll remember it. in that way, these visuals have some animations which will be attractive. And then you have Prof Matt. Prof Matt. This is another YouTube series. Prof Matt means Professor Matt only. So please try to look up these series daily, slowly and steadily. Don't try to see all the series in one day. Okay? Just spend some time daily. It is already a proven fact from your previous certain batch members whom I always suggest these. So just before going to the first of all, when I suggested it, they were also looking into these videos. Few of them, the good ones who were really listening to what I guided them, they were listening to it, and then during the interview, when they went for interview, they just had a quick recap of these things, and they were able to answer comparatively very much well in the interview compared to the students who were not able to answer. And then the student came back and told me that, sir, because you had guided us to watch these visuals, I used to watch it daily this much amount of time, and it definitely helped me to crack the interview, because the way the topic was being presented in the animations with the visualizations and all that got into my head, and I was also able to present it well in the interview. So the presentation also matters. What you get, you are supposed to reproduce that, right? Sometimes what you get from the textbook, what you read from the textbook, you may not be able to properly present it. But what you get from a presentation, an animation or a visualization, you will be able to present it more better. So please look this up. Okay? This will help you revise the analog and digital electronics at a faster pace and a bit more attractive phase than the boring black and white books. So let us start with our topic of discussion. We start with the definition of an embedded system. Take down. Lights will be turned off. Will it not be? Daily, how you used to manage? Daily, how it was? You used to turn off the light? Off. Okay. Which is the button? This one? Okay. Right. Embedded system refers to a combination of hardware and software. Embedded systems refer to a combination of hardware and software. Embedded systems refer to a combination of hardware and software integrated onto a system that is used for a controlled specific application. That is used for a controlled specific application. That is used for a controlled specific application. So this is one way of how we can just try to present what is an embedded system. You can take it like this also. Any system that makes use of, another way of putting it, any system that makes use of at least one programmable device. Any system that makes use of at least one programmable device. Any system that makes use of at least one programmable device. So when I say programmable devices, we can say something like a microprocessor, a microcontroller, a digital signal processor, or digital image processor, okay, and a application specific integrated circuit, a field programmable gate array. You can take an SOC, you can take a PSOC, you can take a PLC, etc. So these are examples of various types of what they call programmable devices in general, PDs. PD stands for programmable devices. Right? So any system that makes use of at least one of these programmable, at least I'm saying, it can be more than at least also. So any system which makes use of at least one of these programmable devices and is used for a controlled specific application. 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 Stop. Okay? So I've given you two ways of how we can define an embedded system. What is the common in the two ways? Controlled specific application is the common thing. So, is this an embedded system? Yes? Yes. Is this an embedded system? Yes. Is this an embedded system? Yes. Is this set up an embedded system? Wrong. Combination of the desktop, in the monitor, with the system box, with the mouse, with the keypad, whatever. This entire system we call it as a general purpose computing system. Your laptop also is an example of a general purpose computing system. So a general purpose computing system is a combination of hardware and software, and embedded computing system also is a combination of hardware and software. So how do we differentiate between them? A general purpose computing system is designed to meet varieties of requirements. Okay, it is having a flexibility where the end user of that system can use that system for varieties of applications. They can create new applications using that system. But when we talk about an embedded system, the end use of that embedded system will be restricted, limited. You don't have the flexibility to use that system for varieties of requirements. You are restricted only to use it for the requirement it has been designed for. So it will not have the support to extend it for other requirements. That's how we differentiate between a general purpose system versus a embedded computing system. So your laptop, your desktops are examples of general purpose computing system, which is also a combination of hardware and software. But your embedded system, which is also a combination of hardware and software, says that the end use is restricted, limited. There, the end use is unlimited. Can be reprogrammed, new applications can be created the way you want. So, let us again draw the picture here. So, as I said, that embedded system is a combination of hardware and software. So, what goes into the hardware I mentioned is programmable devices. Examples of the programmable device: microprocessor, microcontroller, digital signal processor, digital image processor, application specific integrated circuit, FPGA, okay, SOC, PSOC, okay, PLC, etc. So this is your hardware. Apart from this, what goes into your hardware is basic, analog, and digital components. Basic, analog, and digital components. Okay? electrical components. Then electromechanical components. Take note. So this is all what can probably go into your hardware. Okay. Programmable devices, basic analog digital components, basic electrical components, electromechanical components like switches, motors, these are coming under electromechanical components. Next, when you talk about the software, okay, the software is talking about what we call, software is talking about firmware actually. Software talks about firmware. Firmware, another name for firmware is also called as bare metal. Bare metal codes. Okay, the software here talks about firmware, or also called as bare metal codes. So what is meant by the firmware or bare metal codes? Register level, what else? Low level code, okay, very good. So you've added some word called as low level. So what is meant by the term low level code? Machine understandable code. Okay. Or we say machine specific code. So machine specific codes. So when I talk about software, software is basically referred to as firmware. Another name for firmware can be called as bare metal programs or codes, can also be referred to as low level codes, can also be referred to as machine specific. What does this terms mean in English? How do you expand this in English? How do you expand this in explanation? Firmware is a program. Okay, very good. So somebody has said something nice. Firmware here is a kind of code which you write, and that would be the first layer of code that directly talks to the hardware. Okay, it is the first layer of code that directly talks to the hardware. It is not like the C programs that you have written so far up till now. Whatever C programs that you have written, do you have a count of how many programs you have written till today? Just a count. Just a rough picture. Even if you take one program per day, do you do one program per day or at least two programs per day? Two programs per day. Okay, let's take a count of two programs per day. We say 2 months, right? So 2 months means 60 days. 16 to 120 programs. So in each of these 120 programs, did you at any point worry about the underlying hardware? Did you at any point worry about underlying hardware? Did you at any point worry about the underlying architecture? At any register? At any flags? So what programs you have written were hardware independent. You did not worry about the hardware. You just wrote the programs without worrying about the hardware. So those are basically called as your softwares. But when you say firmwares, every statement that you try to write in your firmware programs, you write keeping in mind what is the underlying feature of the architecture or hardware you want to address. What part of the hardware you want to access. Okay, what part of the underlying hardware or architecture you would like to access, you would like to what we call utilize or activate. All that you have to be acquainted with. You have to be acquainted with the architecture of the system. Then only you can proceed with writing your statements. Without getting acquainted with the architecture of the system, you cannot proceed to writing your statements. Clear with this? Following? So, if you take hardware and you want to write program for this hardware using assembly language, 100% of the hardware you need to know before you write the program in assembly language. Now the same hardware you want to write the program in C language. You don't need to know 100% of the hardware. You just need to know some percent of the hardware for you to write the programs in C language, because the C compiler will abstract or hide the rest of the other part of the hardware for you and manage accessing that and making your life comfortable. Following or not? With C language, your benefit is it tries to hide the many hardware level aspects of the architecture and still allows you to access other aspects of the architecture which are required for application specific needs. But in assembly, every part of the hardware in terms of memory, in terms of register, all these things you need to be acquainted, then only you can write the program in assembly. So when firmware is written in assembly language, it is too tedious. But when firmware are written in C, C++, and other higher level languages like Pascal, you have BASIC, okay, Rust. So it gives you a certain level of freedom not to know complete details about the hardware and still talk to the hardware. Clear with that? So when we say firmware, what are the languages? We have assembly as a language, okay? Then we have C, we have C++, we have Pascal, we have BASIC. Somebody was saying RUST Rust. Okay, we have Python, MicroPython, etc. So when you use these languages, these are a bit higher level, but this is the low level. This language differs from architecture to architecture. Means CPU architecture to CPU architecture. This will differ. Many part of this language will be same for the architecture. Some architecture specific operations will be there that will be different. So if I say something like maybe 70% of this language can be used for architecture independent operations, but 30% is required to be used for architecture dependent. So that means your burden is reduced from 100% knowledge to just 30%, because rest of this will be taken by the appropriate compilers for the language. So you just have to know about 30% related to the other parts of the language, compiler will take care. Same thing goes for the other languages. Is it understanding? So what is your focus should be now? C language. Right. So when it comes to software, we say firmware. And what is firmware? I've discussed it right now. Next. Apart from that, we talk about OS, operating system. Anybody can try to define what is an operating system? Very good. So one person is saying operating system is a software between hardware and application. We can also say an operating system is an interface between user and hardware. Okay? An operating system can be acting as an interface between the user and hardware. So how do we define an operating system in a more technical way for an engineer? So when I say operating system is an interface between user and hardware, That is for a non-engineering background student or person. But if I am saying as an engineering background student, how do we answer the definition for what is an operating system? Take note. An operating system refers to a control program. An operating system refers to a control program An operating system refers to a control program with a lot of paraphernalia. With a lot of paraphernalia. Let me put it here for you. Paraphernalia. Paraphernalia. So an operating system is a control program with a lot of paraphernalia. So what is the term paraphernalia? Paraphernalia is talking about, in simple English, lot of stuff. In simple English, it is talking about lot of stuff. In a more technical way, it is called as lot of packages or modules. It's an operating system. It is a huge software. Okay, it's a huge software. Huge software means, can you imagine the number of lines of code? At least a guess. What is the maximum number of lines of code that you have written? At least. Which is your highest number of lines of code that you have written so far till date? 50 lines, 60 lines, 100 lines? Huh? कुछ तो बोलो, say something. Huh? 80 lines. Can you guess? Can you make a wild guess about how many lines of code an operating system, which is a huge software, will probably have? A wild guess. Trillions will be too much, but millions, yes. Trillions is too much, but millions, yes. So millions of lines of codes. Millions of lines of code. Millions is not a small number. Millions of lines of codes are written, and that is the result of your OS. And that result of the OS is what you are enjoying on a daily basis in your mobile phone, on your desktop, on your laptop. So it's not an easy thing. It is something which has come out from efforts of a lot of people. Right? So whatever codes that you're writing in class, these are just peanuts. Peanuts of a code. There is a long way which you have to go from this classroom. So paraphernalia here is talking about lot of stuff. So an operating system is a huge software with a lot of stuff in it. What is this stuff? It has a lot of packages. It has a lot of modules. Why lots of packages? Why lots of modules? Because these modules have to provide lots of services. Okay? It's a bag of services. The operating system is a software with a bag of services. So based on the requirement, the respective service will be taken by the end user. I want this service, I'll have this service. I want that service, I'll have this service. So examples of the services, you have memory management, you have process management, you have file management, you have IO management, you have device management, you have network management. So many services are there. So all these bags of services to be managed require lots of code. Interestingly, you can see your operating system is able to deal with the I have the branding here. Yeah, Dell. Sorry. Your operating system is able to talk to a Dell keyboard, USB wireless Dell keyboard. The same operating system is able to talk to a keyboard which is a wired keyboard, which is a PS2 keyboard. The same operating system is able to talk to a USB keyboard. I'm talking about from Dell. In the same way, the same operating system will be able to talk to what we call microtech keyboard. So varieties of hardware your OS is able to talk to for one kind of input device. What is keyboard? It's an input device. So input devices from various manufacturers. Still your OS is able to talk. How? Because it's equipped with that kind of packages and support and modules that it can identify varieties of hardware from varieties of makers. So that's what I said, that an operating system is a huge software. So it's a control program, we call it. So an operating system is a control program which has been designed to provide convenience for the end user by abstracting the underlying operations of the hardware. Right? Is it noted? An operating system is a control program which provides the convenience to use the. An operating system is a control program which provides the convenience to use. Which provides convenience to use the hardware by abstracting the underlying details, by abstracting the underlying details, by abstracting the underlying details, by abstracting the underlying details and providing an interface in the form of a command line or graphical user interface shell, and providing an interface in the form of a command line or graphical user interface shell. And providing an interface in the form of command line or graphical user interface shell for interacting with. So what is command line shell? It's a way to talk to the computer, correct? So what is command line shell? So if say this is your hardware, if this is your hardware, and here let's say that this is operating system and say this is user. So your operating system is divided into two parts. One is called as the kernel. Next you have the shell. So hardware, operating system and user, or users, user or users. Right, so what is kernel? What is kernel? The main part of an operating system. What do you mean by main part of an operating system? Correct. So main part. Kernel is talking about the core of the operating system. Core means the main processing engine of the OS. The main engine which controls the entire hardware, that is called as the kernel. But apart from that, there is a shell. What is a shell? This shell could be command line shell or it could be a GUI shell. So what is this shell? Shell is also a program. Shell is also a program. And in your Linux, you will now, since I'm in Windows right now, I cannot go to Linux right now. So I'll just go for this let's say command. This is command line shell. So with this kind of environment, what I'll do, I'll give commands. Example of commands, I'll say dir command. So it will list all the directories that are present in the current system, right? So this is a interface where I can type commands and I can get works completed. But apart from that, with the help of the mouse, I'm able to go for a graphical user interface way of controlling the system. So that is called as a GUI shell. So GUI shell is a program, command line shell is also a program, kernel is also a program. So in short, operating system is a big program. What is the purpose of this operating system? It is to provide a convenience for the user to manage the hardware without knowing any details about the hardware. Clear with that? So, embedded systems, in definition, as I said, embedded system is a combination of hardware and software. What goes into your hardware, what goes into your software can simply be a simple firmware. Okay, it can be a simple firmware. When it is going to be simply a firmware, then we simply refer to that as single tasking embedded systems. When it is simply going to be a firmware, we call it as a single tasking embedded systems. When we would like our embedded system to be a multitasking system, a multitasking system means what? Are you doing multitasking in the class? You are not doing. You are doing, right? You are listening to the class. At the same time, you will be trying to take the notes. At the same time, maybe somebody is getting some messages on the mobile phone, and they'll be answering that messages on the mobile phone. Yes. So you are doing multitasking in the class. You are supposed to do single tasking. But if you do single tasking, then if you are only listening and don't take down notes, then at the end of the day again you will complain, sir, notes are not there, please upload the notes. But if I am allowing you to go for multitasking, then you will be listening as well as you will be jotting down some notes. So multitasking is also many a times a requirement in the design of an embedded system. Hence, when multitasking comes in a design of an embedded system, we need the help of an operating system. We only need an operating system when multitasking requirement comes. Multitasking requirement. When it is a single tasking requirement, when it's a single tasking requirement, we have no need for the operating system. But when we go for multitasking requirements, we need the help of an operating system. So multitasking is something that will make the CPU to be used effectively. The effective utilization of the CPU will be better when multitasking is used inside an embedded device. But for multitasking, we need a software to manage that multitasking situation or scenario. So for that, we need the help of an operating system. But an operating system like Windows, an operating system like Linux is not always suitable for varieties of embedded systems. You have lots of varieties of embedded systems. So for the lots of varieties of embedded systems, Windows is not always suitable, Linux is not always suitable, Android is not always suitable like that. So we need to have customized operating systems for varieties of embedded systems, and we call those customized operating systems as embedded operating systems. Embedded operating systems. So customized versions of operating systems, suitable for variety needs of embedded systems. customizable operating systems, suitable for variety needs of embedded systems. We call that as embedded operating systems. You will have lots of embedded operating systems, some which you know very popularly by name, some which you may not know or it is not exposed on the outside, but you will have varieties of embedded operating systems. The prominent operating systems that you know, that you hear daily are Windows, Linux and Android. Yes or no? Apart from Windows, Linux and Android, Mac. Somebody else said Mac. So Windows, Linux, Android and Mac. These are the very prominent operating systems that you get to know. But apart from that, like you have iOS also. Okay? This is what you are hearing daily. Apart from what you hear daily, there are many more operating systems which are used in the industries which are not heard by you, but they are used in the industries because they have been custom designed for meeting the requirement of that embedded application. So when we custom design an operating system, we call it as an embedded operating system. So this embedded operating system can be further customized for time constraints. These embedded operating systems can be further customized for time constraints. What do you mean by time constraints? What can you understand from time constraints? Another name for time constraints is called as deadlines. So when you want an embedded system which has to provide a service within a certain deadline, within a certain time, then you have to now design the operating system in a more careful way and a more responsible way so that it will provide the output in the time that you would like the output in. So a right output in a wrong time in real-time operating system is considered as wrong. So the next kind of operating system, real-time operating system. A right output in a wrong time. A right output in a wrong time is considered as a wrong output. In the case of this, an output in a time acceptable, an output in a wrong time also acceptable. Okay, an output in a wrong time also acceptable. But here, an output in a wrong time is not at all acceptable. That's the characteristics of a real-time operator. So these are more stringent in terms of design. Right? So why do we need EOS or RTOS? Because we would like multitasking. So multitasking is utilizing the CPU to the fullest of its capability. Instead of letting the CPU take rest, sit down, have time to be leisure, we are not giving the time for the CPU to be leisure or taking rest. Every time you will make the CPU do something or the other. That is called as multitasking. But when you go for single tasking, you are not making effective utilization of the CPU. Let us say you are making the CPU take an input from this kind of component. Maybe this input from this component is not going to happen for the next few minutes or few days or a few hours or few days. Then that means the effort of the CPU is only waiting for that input. So while it is waiting for that input, it can also try to take other inputs from other devices. It can also try to do some other outputs with respect to other devices. That is what I mean by multitasking. If you can make the CPU do multiple kinds of activities, multiple kinds of tasks in a time-sharing manner, then we call it as multitasking. Okay, so far, what goes into the software may be a basic firmware for single tasking embedded systems. It may be also an operating system support for multitasking requirements. Next and last part here is talking about support of networking stack. The software may also have a support for networking stack. So what is the purpose of a networking stack? What is the purpose of a networking stack? What is networking? Networking means communications. Networking means communications. Stack means set of protocols. So you'll have a set of protocols inside a system. The collection or set of protocols, we call it as a networking stack. So if there is a collection or set of protocols in one system, what is the purpose? Because you would like that system to have a communication with other systems. It could be a Bluetooth communication, it could be a Wi-Fi communication, it could be a TCP/IP communication, it could be a mobile communication. So varieties of communication. It could be a USB communication. So varieties of different types of communications you would like your system to have. Because it is an embedded system, it needs to interact with other systems also to keep things going and running for the purpose of the design. Hence, it needs the support of a networking stack. So a networking stack is also coming under software. Clear with this? We'll stop here for today. When is your next class? 11? 11? 11:30, 11:15. Somebody saying 11:30, somebody saying 11:15. 11:30 or 11:15? 11:30. 11:30. I still have 10 minutes. Can I continue for 10 minutes or do we stop here? Stop here for today. So I will ask you these questions what I have discussed today, tomorrow also. What is networking stack? What is meant by multitasking? What is real-time operating system in general? What is embedded operating system? What is firmware? What is bare-metal program? I'll ask. So today's discussion was just a generic discussion about embedded systems. You're HE 12, right?
Doon di sana naman lipunan.